So conditional probability is now we will see what is conditional probability. So this conditional probability is very important for any future GATE exams or any other competitive exams. So because this conditional probability has a lot of problems to solve. So by using this conditional probability, we can able to solve many problems. And also in further, by using this conditional probability only, we can also do multiplication theorem. We can also solve the problems in total probability, and also we will see the Bayes theorem problem. So by using this conditional probability, we can also able to solve Bayes theorem problems also. So that's why this conditional probability is very important in coming to mathematics part. Now we will see what do you mean by conditional probability. So it is one of the quite quintessential concepts in probability theory. It means it is very important concept in probability theory. So, so what is probability theory? Conditional probability means it is a measure of the probability of an event occurring given that another event. It means it is a measure of the probability. It means given there are two events. So what it is saying means it is a measure of the probability of an event occurring given that another event was already known. So already we have known another event. So by using that by using that known event, we are we are measuring the probability of the event by knowing the other event. So by using this condition, we'll measure the probability of an event. So how do you measure the probability of event by using this conditional probability means based on the condition. So based on the condition, based on the event which is known, by using that condition, by using that non-event, we can able to measure this probability of an occurring event. So uh, so this is conditional probability. And also what do this method will do means it always relies on event A occurring with some sort of relationship with another event B. It means whatever the event that is happening first, it always relies on event A with which is having some relationship between with another event B. It means there is a relationship between event A and event B. So that's why always this method relies on event A with occurring with some sort of relationship with another event. So yes, is the next point. The Bayes theorem is used to determine the conditional probability of event A given that event B has occurred. So if we want to determine the conditional probability of event A given that B has occurred, it means already event B has occurred, already it has done. So if you want to determine the conditional probability of event A by using the condition of the event B, we have to use this Bayes theorem. So by using this Bayes theorem, we can able to determine the conditional probability of event A given that event B has occurred. So by knowing this conditional probability of event B, given that event A has occurred, given that event A has occurred, mm, also the individual probabilities of event A and event B. It means it means by using this conditional probability formula, you can able to measure the probability of event A and event B by using this conditional probability. So by using this conditional probability, you can able to measure the probability of both the events A and B. So that is what it is saying. And also you can also individually you can find the probabilities of event A and event B. Not only you can able to find the conditional probability, but also you can also able to find individual probabilities of both the events A and B. So by using this conditional probability, you can able to measure the probabilities of individual events. So that is what it is saying. So now we will see the what is the formula of the conditional probability. So the conditional probability formula is given by P of A given B, that equal to so the formula for the conditional probability is P of A given B equal to P of A intersection B. It is nothing but A and B. P of A and B means nothing but P of A intersection B by P of B. So this is the formula for the conditional probability. So what is P of A given B means? Probability of probability of A already given that B event has none. It means already know the event of the B. It means already we have no event of B. So by using that event, we are able to calculate this conditional probability. That is P of A given B. This is the condition probability of A given that B has already occurred. So that is equal to P of A and B. That is nothing but P of A intersection B by P of B. So and also you can see we can also able to write that formula as P of A given B equal to P of A intersection B into P of B. So like that we can able to write. So finally the formula for the conditional probability is P of A given B equal to P of A intersection B into P of B. So now we will see what are those terms. So what is the P of A means? It is the probability of occurrence of event A. P of A is nothing but the probability of occurrence of event A. It is the event A which we measure the probability of that event. So P of B means probability of occurrence of an event B. It means P of B is nothing but the probability of occurrence of event B. So next one, P of A intersection B. So what is P of A intersection B implies? It implies that both events A and B have occurred are the common elements of the event. P of A intersection B means common elements of the events, or we can also able to say that A and B have occurred. So we can able to say P of A intersection is nothing but the common elements of the both the A and B are A and B have occurred. So that is what it is saying. So now we will see the examples. Now we will discuss examples. See, first question. If P of A equal to 0.3, P of B equal to 0.7, and P of A intersection B equal to 0.1. Now they are asking P of A given B and P of B given A. So now we have to find the conditional probability. So what is the first question? Find the probability of event A given that event B has occurred. So already we have P of what is the formula for P of A given B? So P of A, P of A given, P of B given, and also we have known P of A intersection B. Now we are going with the formula. So what is the formula for P of A given B? It means probability of A given that even B has occurred equal to P of A intersection B divided by P of B. So that is the formula for the conditional probability. Now substitute in it. What is the probability of P of A intersection B? Value 0.1 divided by what is the value of P of B? 0.7. 0.7. So after that we will get after that simplification I got 1 by 7. So P of A given B equal to 1 by 7. Now we have to calculate as well as P of B given B. So P of B given B. It is also same like a P of A given B, but the denominator will change. So so for P of A given B, P of A intersection B by P of B. So whatever the event that has known, we have to write that non-event in in the denominator part. That's why we have written P of B in the denominator part. Here also P of B given is. It means already event A has already occurred. So whatever the event that has already occurred, we have to write that in denominator. That's why I am getting P of A intersection B by P of A. Already we know the value of 0.1 by P of A intersection B and P of A. What is the value? 0.1 by 0 equal to 1 by 3. So that is the answer. So go to next, we'll see the next question. Now see the second question. If P of A equal to 0.2, P of B given A equal to 0.8, and P of A intersection B equal to 0.3, then find P of B. It means they are asking the probability of P of A in A B. Now we'll see how to find that. So we have P of A, next P of B given A, and P of A intersection B. So now we will see how we will write this P of A and what P of A union B. Sorry, they have given P of A union B. So now we will see how to find this P of A intersection B. If we want to find the P of B, we have to know the P of A value, P of A intersection B value, P of A union B value. So now I am finding P of A intersection B. So how do we find this P of A intersection B means P of B given A into P of A, because already we have known the conditional probability P of B given A equal to P of A intersection B by P of A. So from that we have to find the P of A intersection B. So from that P of A intersection B equal to P of B given A into P of A. Now calculate the value P of B given A value is 0.2, P of A value is 0.8. So now what is the value? 0.16. Now P of A intersection B equal, now we will find the value. Now we will find the value of P of B. So in order to find the PR value of P of B, now we'll see now in using this formula P of A intersection B equal to P of A plus P of B minus P of A union B. Already in the axioms of probability we have seen this. So also we can also write P of A union B equal to P of A plus P of B minus P of A intersection B. Likewise, we can also able to write P of A intersection B equal to P of A plus P of B, P of A intersection B. So from that, I want to find the P of B. So get the P of B value, P of B equal to, so take these two values from the left side, so that plus will be changed to minus, minus will be changed to plus. So P of A intersection B minus P of A plus P of A intersection B. So we know all the values of this. So substitute the values and we'll get the P of B that equal to 0.26. So finally we got the solution probability of event B equal to 0.26. So likewise, we have to find the solution for the given problem. So next problem we can even see. So next question. A dice is rolled. Suppose a dice is rolled. If x equal to 1 to 6. Suppose for x, in the x we got the values in the sets like 1 to 6. And the y values are containing 2 and 4. And the z values are containing 2, 4 and 6. So now find p of x given by and p of x given z. It means we have to find the conditional probability given that y has occurred and given that z has occurred. Now we'll see the first one, probability of x given y, event of y already has occurred. Now we will see already we have x values, y values, z values. Now I want to find the probability of x. It means n of x equal to 3. It means I am having 3 values. Next, number of values in y equal to 2. Next, number of values in z equal to 3. Now, and I have to find the intersection part of x and y. So what are the common elements in the x and y? Only one common element. That's why I am writing n of x intersection y equal to 1. Next, what are the common elements between x and z means 2 and 6. That's why n of x intersection z equal to 2. Now by using this formula, I am calculating probability of x given that y event y has already occurred, that equal to n of x intersection y by n of y. Already we know the what of x intersection y. It means common elements between the x and y, that equal to 1, and by number of elements in y 2. So the probability of x given uh, probability of x given y equal to 1 by 2. And if we want to find the probability of x given, already z event has occurred equal to n of x intersection z given by n of z. So already we know that n of x intersection z that is equal to 2 by n of z equal to 3. So the probability of x intersection z equal x given z equal to 2 by 3. That is the value. Now we will see the fourth question. Suppose a coin is tossed to 3 times. So there is a coin. We toss that coin 3 times. Find the conditional probability P of C given D, where C equal to head on first toss and D equal to tail on second toss. It means they are asking about the conditional probability. So P of C given D, that is probability of head on first toss by tail on second toss. So now we will see the sample space. It means the total number of possible outcomes. So what is the sample space for that? Head, 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 tail, head, tail, tail, head, tail, head, tail. Now I have to calculate P of C given D. If I want to calculate P of C given D, I have to know the P of C value, P of D value, and also P of C intersection D. It means the common elements. Now I have to see how many elements are there. Number of elements P of n of C equal to 4. Why n of C equal to 4 means first toss should be head. Remaining second toss should be tail. Like that, how many elements are there? 1, 2, 3, 4. Total 4 elements are there. So what are the head, tail, and tail. So n of C equal to 4. N of D. What is the n of D? Heads on first, n of C equal to heads on first half. It means head should be present in first half. So how many possibilities are there? Head is 1, head is 2, head is 3, tail is 4. So number of heads on first half is equal to 4. Next one, number of tails on second tail. So we have to calculate that. So on second tail, how many are possibilities are there? 1, 2, 3, 4. Total 4 possibilities are there. So n of d equal to 4. Now I have to calculate probability of head on first toss. So out of 8, there are 4. 4 by 8 equal to 1 by 2. Likewise, probability of tail on second toss equal to 4 by 8, that equal to 1 by 2. Now I have to find the common part. So what are the common parts between the N of C, P of C and P of D? It means P of C intersection D. So how many common elements are there? So heads on first toss and tails on second toss. Take the samples, tail, take the head, tail, next one tail, head, and tail, head. And next one should be, on the next one, there should be, in the second position, there should be tail. So from that four, how many are there? How many tails are there in the second position? There are 2. So our total 2 common elements are there between heads on first toss and tail on second toss. So that equal to 2 by 8, that equal to 1 by 4. So we know the value of P of C, P of D, and P of C intersection D. Now we will find the value of probability of C given D equal to probability of C intersection D by P of D. What is the value of P of C intersection D? 1 by 4 by P of D. 1 by 4 by 1 by 2 equal to 1 by 2. So that is the value of P of C given D. Thus, next, calculate the next fifth question. Given that probability of A given B equal to 3 by 7. Already we have known the conditional probability value, that is 3 by 7. Find the conditional probability of A complementary given B. So how can we write A complementary given B means already we are having the property, that is P of A complementary B given B equal to 1 minus P of A given B. So what is 1 minus, what is the value of P of A given B? 3 by 7. So 1 minus 3 by 7 equal to 4 by 7. So finally P of A complementary given B equal to 4 by 7. That is next one. Next example. Evaluate P of X union Y. They are asking to find the value of x union y. So they are given the value 3 times probability of x equal to probability of y equal to 2 by 5 and probability of x given y equal to 4 by 5. Now we will see, now we will calculate each and everything. We will calculate p of x value, p of y value, and already they have given the conditional probability. What is 3 times p of x equal to 2 by 5. P of x equal to 2 by 5 into 2 by 5 by 3 means 2 by 5 into 3. That is 2 by 15. Next, what is the value of probability of y means 2 by 5. Already we are next one. By using this conditional probability formula, P of x intersection y equal to P of x even y into probability of y. So what is the probability of x intersection y? P of x given by 4 by 5 into what is the value of probability of y 2 by 5 that equal to 8 by 25. It means if you want to calculate the probability of x union y, you need to know the value of x intersection y because the formula for P of x union y equal to probability of x plus probability of y minus P of x union y. So we have to calculate each and everything. From that we have to derive. So now we will see P of x union y equal to P of x. What is the value of P of x? 2 by 15 plus. What is the value of P of y? 2 by 5 minus what is the value of P of x intersection by 8 by 25. So by solving that, I got the answer 16 by 25. So that is the final solution. Next example. In a school, there are 100 students, out of which are 40 boys. So suppose there is a school. So in the school there are 100 students. Out of 100 students, 40 are boys. It means 40 are boys means remaining 60 are girls. So and also it is known that out of 40, 20% of boys study in class 11. So out of 40 students, 20% of the 40 people are studying class 11. So they are asking to find what is the probability of A given B. So so where A is student chosen is a boy. It means we have to choose given that the student is boy. So we have to take from the boy only. So that is one. Now we will see how to do this problem. So now we will calculate what of P of n intersection B that equal to, it means common things. It means if we want to calculate n of A intersection B equal to 20% into 40. Y means 20% of Y into 40 that equal to 80. It means common people. If we want to calculate the common people between those two, we have to calculate n of A intersection B. From that we got the value 8. Next, n of B. So what is the value of n of B? N of B means nothing but number of boys from that 100 students that equal to 40. So by using this conditional probability formula, P of A given B equal to P of A intersection B by P of B. So what is the value of P of A intersection B? Already we have calculated, we got the value 8. And by what is the value of probability of B? 40. So probability of A given B equal to 1 by 5. So that is the final solution. So that is. Now we will see the ninth question. A coin is tossed two times. Suppose we tossed the coin two times. So they are asking for find the probability of y given x if here they have given the condition, say x equal to at least one head and y equal to no tail. X means at least in first in X we have to have one head and Y there should be no tail. So from the given condition we have to calculate the property of Y given X. So whenever we toss two coins, we have to take the sample space from the two coins toss. So what is the sample space? What is the possible outcomes? Head tail, tail head, and tail tail. So what are they asking? Probability of X, at least one head. It means there should be having at least one head. So at least one head means head tail, tail head. So we are having three possibilities. That's why probability of X, probability of having at least one head equal to 3 by 4. Next, Y, no tail. Means there should be no tail means there is only one possibility, that is head. That is the probability of having no tail is 1 by 4. Now we have to calculate the value probability of y given x equal to probability of x intersection y by p of probability of x. So already we know the value probability of x and also probability of x and y. So what is the common part between x and y? Only only one possibility, head. That's why probability of x intersection y equal to 1 by 4. Only one common element out of 4. So that's why it is probability of 1 by 4. So now we calculate 1 by 4 by 3 by 4, that equal to 1 by 3. So finally I got the value of probability of y given x equal to 1 by 3. This is the ultimate solution for the given problem. Now finally we'll see the last question. So a coin is tossed three times. Suppose we toss the coin three times. Find x given by. So what x given by x equal to what is the probability of x means they are giving the condition at most one head. It means maximum one head. Next y equal to at most two tails. It means only maximum two tails. Now we will see the sample space. So those are the sample spaces, 8 possible outcomes. Now we'll calculate what is the probability of at most one head. It means we should have only one head. So what is the how many possibilities are there? One, two, three, 4. So out of 8, we have only 4. So 4 by 8 equal to 1 by 2. Next, probability of having at most two tails. It means maximum two tails only should be present. So this one, this one, this one, this one, 5, 6, and 7. So at most two tails means we can also have zero tails also. So out of 8, there are 7 possibilities. So that is probability of y equal to 7 by 8. Now we have to calculate the intersection part. So P of x intersection y equal to what are the common elements between at most one head and at most two tails means at most one head and at most two tails. So from at most one head we have to take at most two tails. So 1, 2, and 3. So out of 4 we have only 3 possibilities. Now we will calculate the conditional probability. So P of x given y equal to P of x intersection y by P of y. Already we know the number of common elements between x and y. That is P of x intersection y value is 3 by 8 by probability of y. So what is the value of probability of y? 7 by 8. That equal to probability of x given y equal to 3 by 7. So this is the conditional probability concept, guys. Hope everyone understood and I hope everyone got the clear understanding. So if you really understood this class, please like and share, subscribe the channel, and also please comment CFBR in the comment section so that it would be helpful for me. So if you want more videos in the future, please comment in the comment section so that I can able to make more videos whatever you want. So now I am winding up this session. Bye bye guys.